there, portion. Okay, so that's not it. Here you go. And you can see that just fine. Sorry about the noise, man.
No, it's all good.
Okay, so if you want to just look at your basic one here, this hopefully looks familiar. This is just your kind of standard axis, right? Where independent goes up, vertical axis, and that would be like X for position. I'm not sure, you might be using R, which would usually include both the X and Y position. But if we just start out basic here, this depends on time, right? So as time goes by, I'm going to do some position, right? This is me moving away from the origin here, right? So you're not going to see something crazy like that. You might see something like this. Let's just make it real basic. So this is a position versus time graph. So we can tell what the velocity is doing based on the slope of the graph at any given time. Let me even add some times here. We'll call it just T1. These are variables, right? So they don't matter. I don't care what you call them. And okay, T1, that looks like it's about there. And let's use a different color. T2 is at the top and T3 is about there, right? So already I know with just this information, I know what the velocity is doing. And so right here, the velocity is greater than 0. It's speeding up, it's getting faster. Or the velocity, it's moving away from the origin, sorry. And the way that I know that is because this is a positive slope. So all you have to do is look at the slope of that tangent line. If that's too much, that's okay. It's just the line at that point, right? So is that pretty good for you?
Yeah.
Okay, cool. And so let me ask you then, what would the velocity be at that point, at the height of this graph here?
Would it be 0?
You got it, man. Exactly. And why? Because the slope of that line is 0, which means that it's not moving anymore. Now, before we talk about that one, because there's only one other option, right? This is equal to 0, so obviously that's less than 0. But the point is, what is the slope line? That's all you got to ask yourself. That's why the velocity is decreasing, or it's getting smaller, right? Could be getting really fast in the negative direction, but remember, velocity is a vector, so it's relative to some point. That's what we're talking about here. And so that's what you got there. And you might see something like that. Even there's one other possibility you might see, but it's the same thing. I don't care what it looks like. It's what is the slope of the line there? And you might already recognize, well, the one that's 0 is easy, right? A minimum or maximum, but only on the X versus T graph, right? You might have something else, and you got to pay attention to what your variables are. So, but what about the acceleration also? You know about that? I mean, what it's doing based on this graph?
No.
So concavity, if you've heard of that, it's basically, since this is concave down, upside down smiley face, sometimes we think about it when you're first learning it, right?
Right.
That means the acceleration is negative, or the acceleration is less than 0. Why? Because this thing is concave, or upside down cup, upside down bowl. And what does that mean? Well, its velocity is decreasing, because remember, these things are related. Are you guys dealing with derivatives at all?
Like in physics?
Yeah, in your physics class right now, yeah.
The only thing he just told us that velocity is derivative of position, acceleration is derivative of velocity. That's all he said about it.
Yeah. So that honestly is such a powerful concept, but it doesn't really help if you're not like really comfortable with derivatives and know a decent calculus. So how are you like personally?
Are you very comfortable with derivatives?
Oh, that's perfect. Then it's perfect, because physics is actually easier in calculus, at least trying to understand it, because that's the natural language of physics.
I'm in calculus 2 right now, so we're just doing anti-derivatives.
Yeah, nice. So you just started that one. Cool.
Right. Yeah.
So then you know that, okay, if I'm going to take the derivative, and it's exactly what you just said, man, that's the velocity. Well, what does that mean? This velocity is telling me how fast the position is changing. And of course, it's relative to some origin. I got lost my train of thought there. But then if this is true, then the second derivative of position, well, that must be acceleration, which sounds like you're pretty comfortable with that idea. And so that's how we get to there. Okay, so I don't know why he didn't send this. Let me send you my
Well,
number in the.
can I ask like about another graph?
Of course,
You
yeah,
gave
dude.
me, so it's a graph that's shaped like, how do I explain this? Like it starts at the origin and it kind of gradually starts to increase. I don't know if that's a good description.
Position on the vertical axis.
Yeah.
Okay, it starts at the origin and then it kind of like a line, or
Yes, like
okay,
that.
line. Oh no, okay, like that, and then so
Yep,
maybe
keep
you're
going.
saying just like that.
Yes.
Okay, so again, man, it's about the concept. What is the velocity doing? I'm asking you now. What is the velocity doing? Pick a
It's
point.
increasing.
It's increasing. Why? Well, okay, sorry. The velocity. You got to be careful with the words. The velocity is positive,
Okay.
and that's because the position is increasing. Make sense?
Uh-huh.
And then so look at how it's increasing. Let me write this graph before I go into that. Just a straight line. Well, look, velocity is also positive. Why? Because this thing is increasing with respect to time.
Mhm.
But I'll tell you, the acceleration here is actually 0, but the acceleration here is positive.
Okay, I understand.
Yeah.
That makes that concave up and down really
It,
made me understand it better.
that's key to this. And then a little bit further is like, well, how fast is this thing increasing, man? Well, it's increasing at an increasing rate.
Mhm.
And then that's concavity, obviously, but hopefully that sounds like it drove it home for you. And then take a look at this guy here. Well, it's not increasing at an increasing rate. It's increasing at a constant rate, right?
Right.
So that's why acceleration there is 0.
Okay.
So you got, do you want anything else on these graphs? Because the pictures did actually just come in.
What would it look, what would those graphs look like on
Velocity versus time.
velocity and acceleration ones?
You got it, dude. So you want asking about this, right? V versus T.
Yes.
Okay, so let's write one. Let's just do that same one, right?
Mhm.
So you already know this. I'm gonna write this down, and you know this, but what does that mean? I mean, look at this. D of whatever, the derivative with respect to time of the position function. Well, that's velocity. That tells me the slope of the line. What's it doing? You know that's increasing.
Mhm.
Well, this is velocity. This is the same relationship as position and velocity. So this is the exact same. Acceleration is definitely positive. Why? Because it's increasing. Just like on this graph here, if I go here, and I draw you my straight line, well, of course, what's the slope of the line? That's all I'm asking. What's the slope of the line?
Mhm.
When you want to determine the acceleration, like you said. And then you can go backwards, and a little thing they don't usually ask you this, but as you know, now you're in Calc 2, but you probably already knew about integrals, and like that's the reverse of the derivatives.
Mhm.
And so just like it sounds like you understand very well that the derivative is the slope of the line. Well, now what is the integral? The area under the curve
Right.
above the axis. And they
Mhm.
say above the x-axis. I don't care what it is. It's not the x, it's not the t, it's the independent variable, whatever that is. So this area. So then you can say, well, looks like, and that's my position. That's how you go backwards.
Mhm.
And so if I can do that for you, well, that's position. Sorry if you're using R, the notation. It sounds like you're pretty comfortable with variables, so it's okay. But
Yeah.
this is position, right?
Mhm.
And so that's what this integral represents, the area under the curve. And then you mentioned about acceleration. Oh, by the way, the derivative, if you're wondering, I'm not sure if you're in, what's your major? What are you doing? Engineering?
Mechanical engineering. Yep.
Oh, well, then this is perfect for you. So this actually does apply, especially aerospace. I'm not sure mechanical, but it's all kind of
Yeah, it's all the same thing, really.
derivative of acceleration that exists. Obviously, we call it jerk. And what would the jerk be here? You're not going to see this in your physics class, but this is concave up. And the second derivative of velocity, right, is jerk, because the derivative of acceleration, you can get as complicated you want, but so there is something there, right? Okay,
Right.
I just want to mention that. Do you have any other questions on these pictures here? Or sorry, the graphs, before I get into the pictures?
No, we can go ahead and start the pictures. we're gonna have another appointments. I'm gonna make more appointments this week. So
Okay, sure.
if
Yeah,
you have any more questions, I will.
that's smart. If you got the test on Friday, just to be safe, you know what I mean?
Yeah, I also meet with Matthew because I got a
Calc 2 test also.
on Monday.
Yeah, okay.
Yep.
Okay, so give me just a few
Now
seconds
I
here.
sent the pictures. They're just the questions. I can't fit the questions. Just how the page is like organized. So I'll tell you
The questions that they
the
ask.
questions that go with it. Yeah.
Okay, sounds good.
I just gotta find them.
Um, hopefully that works. Okay. Okay, we got it in here. I'm looking at the first picture. We got driving down the highway late one night
Hmm.
at 20 meters per second when a deer steps on the road. A big deer, 44 meters in front of you. Okay, your reaction time. Okay, so you look at this and you already know that it's constant acceleration problem, but they're not going to tell you that on the test. And so you say, what type of problem is this? If you can, and that's going to guide you here. Sorry, get this thing out of the way. Okay, so when you're doing constant acceleration in one dimension, and the reason you know that it's not projectile motion because you're along the road, you know, you're not falling, you're not throwing anything. So that's kind of helps you out here because you already want to think about your equations. Now, the first thing you do in any physics problem ever for the rest of your life, probably, hopefully, you want to, I call it, I have a little thing that I made. I call it epic. The first thing is extract. Extract what? Read the problem and extract the given information. So what does that mean? Driving down the highway late one night. Okay, driving down the highway, that tells me it's one dimension kind of at 20 meters per second. What is that? That's a velocity, right? Tell me, I sometimes get to go too fast. So please interrupt me,
No, you're
tell me to
good.
slow down, shut up, or whatever you need, man. It's your
Yeah,
time. You know what I mean?
you're good. You're good.
Okay, cool. So I know it's a velocity. Why? Because meters per second, the units tell you that. So you say, whatever variable you're using, you're probably using V, maybe VI.
We use VI or V
Yeah.
naught for the
Okay,
initial.
good to know. That information is useful. So you know it's your initial. Are you comfortable with that? Do you have any
Yep.
questions about why? Okay,
That's
good.
fine.
When a deer steps onto the road, 44 meters. So that's a distance, right? Because meters. But I also want to segue here. Epic means EPIC. And so picture is what's next. This really helps you. And you can extract all the information first. And you would say, I guess you would say X here, 44 meters. And then go through, okay, I got a time, and then I got an acceleration, or you can extract and draw your picture at the same time, whatever works best for you. You can even draw the picture first and then put in the information, but both are needed in general to at least be good at this. So what does that look like? I have an origin. This is where it starts. You can put an O, you can put whatever you want. I don't usually put anything, but then somewhere down here, I don't care where it is, right? It's a graph. And so, well, what is that? There's the deer. He just stepped out in front of me. You can draw a nice picture if you want. But really important here is to label. You say, that distance right there, that's what that is. That's my X. And it really helps to bring it together with the visualization, to really just understand what's going on completely, because you do need that to be able to do well, at least, do well in the test or whatever. And then sometimes you can write a velocity and you say, okay, I'm going in this direction because, of course, you probably know velocity is a vector. So by doing this, I'm saying, well, to the right is my positive direction. Positive X is this way. And that's important too. It's not too important here, but it can be really important. 20 meters per second. And let's see, reaction time before stepping on the brake. So here you go. You get in again. I'm reading the problem. I say, oh, reaction time. Now they're telling me, as well as I give units. Are you using delta T or just T?
Just T.
Okay, so that can it's nice and compact, but it can screw you up later if you forget that this is actually a time interval. It's not an instant in time, it's a time interval. It is actually delta T, which of course is 2 points in time, where we have, well, this is the final time when you crash into this guy or not, maybe we'll find out. And there's your initial. Okay. And so it really is, but as long as you got to keep track, right?
Oh, we do use delta X for the distance.
Okay, that's fine. And that's a good point because it actually is not a single point. I think you get that part. Okay. And then maximum deceleration, good enough. 10 meters per second, but I've made a mistake already because deceleration means minus sign. And it's because my positive direction is to the right. But the acceleration, well, it just told me the acceleration is that way. And then if you think about what's actually happening, because you can actually do it in this one, like drive down the road and okay, I'm driving that way. Well, my acceleration better be that I better not be accelerating that way, or I'm not only going to kill the deer, I'm going to kill myself, right? Like it's going to be bad. Okay, so then you gotta, this is the whole thing kind of, let me make sure. Yeah, this is the setup, extract picture. Any combination, doesn't matter, whatever works best for you. EPIC means identify. And again, this works, I don't care, this will work for electricity and magnetism, pretty much any physics problem you want to solve. Try to remember this. Identify what? The equation that relates all of your variables, right? And so you might have an equation sheet. If not, you got to do more practice, and so you make sure you remember. But let me
Yeah, we have to memorize them. There's only 3 of them. It's not really. Or actually,
yeah,
there's like 5.
Yeah. Okay. So for constant acceleration. Oh yeah. So now, okay, sorry. The last part of the extract is what do they want you to find? And so I guess that's where you got to tell me, unless you sent me it. No. Okay. So what's the first thing they want here?
Oh,
They're asking for.
How much distance is between you and the deer when you come to a stop?
Okay. So they essentially want, okay. So they want an XF, and this is what you do. And you can say question mark. So not only identify the equation that relates all of your given, but also what you need, right? So you got to be careful about saying, okay, delta X, this actually isn't useful here. It will be to figure out the distance between your final distance, but let me clarify it. What you're trying to find here is the final distance. And so it's a new kind of delta X wherever your stopping point is, right? This distance. Because that's pretty important to like recognize and just tell yourself as you're doing this. And then of course, the answer that you're going to put in, it sounds like, is going to be that distance there. So which equation should I use?
Hang on. Probably the delta X equals V naught times time plus 1/2 acceleration time.
Yeah, you got him. Exactly. So this might be, I'm not sure if this is exactly it, but this is the most general. And so, but you say, oh, what is that? Actually, do you guys, is X not in your equation at all?
It's V naught.
Okay, but V naught T over here. Okay.
That X naught is not in there at all.
Okay, yeah. That means
delta X represents both of them.
Yeah. The difference between them, right?
Right. Okay, I understand. Okay, I get it actually.
Yeah. And the X naught, it is in there generally, but if you choose your origin to be X naught, then it's always 0. So that's why it doesn't show up for yours. So, well, guess what? We have all these, and this is actually, you just plug in the numbers here. Do you need to go through that at all, or see that? It's fine if you do.
No, that's fine. I'm good.
Okay, cool. And then I assume that's right. So what's the next one that they need there?
What do you mean?
The next thing they're asking for in the Pearson.
What is the maximum speed you could have and still not hit the deer?
Oh, sorry. One thing I wanted to say here is this, remember, I did say before, the XF, that's your thing there. That's not what you're going to put in. You got to subtract 44 from that to get the correct answer, I believe. If they're asking for the final distance between the deer, right? If they're asking for that distance. Okay, sorry. So it's velocity. Which velocity do they want? Or is it just, you can read it again.
What is the maximum speed you could have and still not hit the deer?
Okay, so
final velocity.
Yeah, final velocity. You got it exactly. Wait, what is the maximum velocity you could have without hitting the deer?
Yes.
So it's the initial velocity. I'm pretty sure, because now you are going to use this 44 meters and use that difference there and then solve for V naught. I'm pretty sure, because you're given the same acceleration and you're given your reaction time. which is the important piece there. And so, yeah, you're just, sorry, I got some lag on this thing. Where is that? So yeah, your same equation here, but instead v naught t plus 1/2 at squared. Well, then now use your algebra, which you may, sounds like you might be okay with, to solve for this value v naught, right? So the final thing, I guess, would be, I guess it's just xf over.
Oh, the thing is lagging a lot right now.
Yeah, it's having an issue. Let me see, just see if I can fix that real quick. Ah, shit. Come on, baby. Sorry. This is just great.
I'm gonna run to the bathroom real quick.
Yeah, sorry, man. That's fine. Yeah. Fuck, man. Hey, there we go.
You get it fixed?
Yeah, sorry about that,
All
man.
right.
We can make up for it
You good?
at the end or next lesson. Get some time. Okay, sorry. All right, let me get where we're going here. We got a train of thought. The velocity, that should be what the answer is. Okay, and then we're going to solve for v naught. So you subtract that, divide by t. So it would be, just real quick to get that guy, and then divided by t would be your initial velocity, I assume. And then you got to remember to be careful with that acceleration value, not in like projectile motion where it's always like minus 9.8. You got to make sure you put in, because you're going to get your the wrong answer if you don't put in the right numbers. Okay, we got. Are there more parts for this guy?
Nope, it was just 2 parts for that one.
Sweet. So let's should be able to, let's see if we can. So you're good with the speed and everything, and then is there anything that I could do better to better help you? You know what I mean? If any
Well,
feedback.
I just need to. My main problem is like knowing which equations to use and when.
Okay, you had that to give you some to give you a little bit of confidence booster there. Like you knew exactly which equation to use, and so you're doing pretty well here. All right, I'm going to get on to Porsche challenges Honda. I thought the Honda was challenging the Porsche. I was like, idiot, what are you doing? All right, 100-meter race, fine. So right away, again, I highly encourage you to do this. I stopped writing that. It says it's just extract, and that's what I remember. You say, okay, well, delta x here, because this will help you choose the equation too once you have it all written down and everything in front of you. Now it's a little bit different here, and you got to be careful with your variables. This is a strength that you should, if you don't have it already, we're going to want to develop this, where you get very, very comfortable with your variables. And so the acceleration of the Porsche, that's what they give me. And so, well, it's not just A, that's not good enough, right? It needs to be A subscript P,
Right.
because there's two accelerations.
Right.
So we got that. You're probably comfortable here. Equals 3.0. I don't like that, but I guess it reminds us the Honda gets a 1 second head start. Okay, so we want to definitely draw a picture here. And so you're going to use the same equation, but you got to be careful. So let's see what we got here. Draw this. There's our distance. Okay, at t equals 1. What does that mean? The Honda starts moving. So that's when it goes. Some more information they give you is the initial velocity, or V naught P, the initial velocity of the Porsche, is 0. Does that make sense?
Yep.
Good. That's a crucial piece there that a lot of people sometimes overlook, but that's good if you're there. And the initial velocity of the Honda, of course, is also 0. So now we say, okay, oh yeah, what's the first thing they're asking for? What do they want from us?
They're just asking who wins and by how many seconds.
Okay. So you have to ask yourself, they're at the thing you want here is how much time does it take for each one? So TH, what is that? And TP, because that'll tell you, obviously, whichever car can go the same distance in a shorter amount of time wins the race. Now, that's obviously obvious if you're thinking about a car race, but it's important to say that and be explicit when you're doing the physics problem, right? So let's look at it. The equation we want is the same one, and the reasoning is very important. You say, why? Let me write it down. This is our equation, delta x v naught t plus 1/2 a, the most general form. Great. And you say, well, how do you know that? Why? Well, you got to really say, what do I have and what do they want? Does the equation relate those things? It's really as simple as that, but obviously, it can be more difficult if you're doing it on your own. You don't have the guidance. But the trick here, you say, okay, I got that one. This is all given. There's an acceleration. I called it AP, but that's just a special acceleration for a particular car. It is that A, right?
Right.
That acceleration, as long as you use the same initial variables, right? And so we're actually ready to put it in here, and we say, okay, let's solve for the Porsche because it's a better car. So then I say, oh, here's another trick. Always solve for your variable first. It's a good thing to do. So we're solving for, if we want to rewrite this thing, let's actually, what do I want to do here? Let's get rid of it. Delta x is the same. I don't need any variables there. V naught P T P. And again, just be very aware and conscious of what variables you're using. And it doesn't look like the same equation as your equation sheet, but I promise you it is, right? And now solve for TP. And we ask ourselves, well, can I solve for TP? Well, yes, I have that, and I have that, and I have that. So yes, I just have one variable left. Now, depending on how good your algebra is, right? Okay, I guess we have to do quadratic equation for this. I hate that.
Or could a different equation, could we use
yeah, go ahead.
final velocity squared equals V naught squared plus 2 times acceleration times delta x.
So we can't, we might be able to in a different problem, but we can't here because we don't have the final velocity. When you have,
right, okay.
Yeah, the deal about, it's a math theorem, right? If you have, 2 unknowns, well, you better have 2 equations at least to solve them, right? Okay. Yeah. So then but you're right. Let's go through the thing, because this is the task. This is what you do. Which equation do I use? And you say, okay, what's your other one? You might have this one. Yeah, you should have, what is it? VI or V naught plus AT. And it's like, Oh, does
Yeah.
this one help? Well, no, because I have two unknowns, right?
Right. So you want to, when you're trying to find something, you don't want to have two unknowns. You want to have one.
Yeah,
That's how you pick your equation.
as much as it is in your power to do that, yes. And
Okay.
occasionally the hardest ones you'll see, they don't let you. You have to
Mhm.
solve for one and then plug it into another. But yeah, you're right.
Mhm.
And then what's the other one? There's that's the third one, and then there's a fourth one at least, and it should be I don't have it. What's the other equation on there? Just
It's mainly those three mainly,
okay.
and then
I hate that. Oh, it's like 2a delta x. No, that's the one you said, right?
yeah,
Okay.
that's what I just said. What is it?
I hate that. Well, we know that we can
What,
solve for this. Go
what
ahead.
we're
Yeah.
doing, what we're doing now is
Yeah.
so what's it called? It's the one for circles. That doesn't apply to this one, obviously. To these ones.
So yeah.
Okay, yeah, sorry. Go ahead.
No, you're good. So yeah, so now EPIC epic calculate at the end. We identified the equation, now you calculate. And it might be difficult like it is here. I mean, it's not that hard, but it's quadratic equation, which you gotta, oh, what the hell's that? And then put in the numbers and do everything right.
Mhm.
Do you wanna see that?
Yes.
Okay, cool. In general, okay. This is a quadratic equation. Do you recognize? It's okay if you don't, but do you recognize that?
Yes.
Okay, to use the quadratic equation and solve for your independent variable, which happens to be TP here, and if you know it's a quadratic equation, it's because that's squared, of course.
Mhm.
And then you have your kind of linear variable here. But what's the general equation? Let's write it down. It's minus b plus or minus, because you got two solutions. Quadratic always has two solutions. B squared minus 4ac divided by 2a, right?
Mhm.
And then you say, okay, this doesn't help me. A, B, and C, I don't have that. But what you want to do, maybe, is get everything on one side. So the thing is equal to 0. This is called standard form of a quadratic equation. So minus delta x equals 0. Be real careful what you're doing. And so A, B, and C are the coefficients to your variable. If this is my squared, that thing's my squared variable, right? Well, this is a constant. That's A. If this is my linear variable, right? Linear as in to the power of 1, that's B. And then this thing is C.
Okay.
When you set it equal to 0, but only when you set it equal to 0.
Mhm.
So then you go through and you would do that. And you have the values here. So yeah, we can do that. Minus B, just real quick. So then obviously it's just associating. Oh yeah, B is 0, so that helps us. Great. Because the initial velocity is 0. Okay, good. Got to make sure we're careful. I'm going to just be real careful here. Minus 4, what was A? Is the acceleration. So 3.5 divided by 2 is 7/4, maybe? Yeah. And then C is our one with no variable, right? Just a number. And it's minus 100. And we say, oh, that's a good sign because, well, this is called the discriminant, and that thing under the square root, well, that better be positive, or I have to restart because I didn't do it right. And then 1/2, okay, whatever, 2 times 1/2 times AP, which is 3.5 or 7/2. Those go away. Hooray for us. We can cancel out the 4s. So it looks like 700, square root of 700 divided by 3.5. Yeah, fine. And then they probably want, well, how many did they give us? They want 2 significant figures. So square root 700 divided by 3.5 should be 7.56. And then you say, oh, and we didn't talk about this before, but every physics problem you go in and you say, is that reasonable? Does that make sense? And
I'm sorry. Hey, where did you get the 2 times 1/2, 3 times 3.5?
so in my quadratic formula, Yeah, it's confusing with the A kind of here, right? But
Mhm.
this is the quadratic formula in general, like the
Oh, right,
up,
right. Okay, okay. I see.
and then A is here, 1/2
Yes.
AP.
Okay.
Okay, cool.
Yep.
So
Yep.
then you always want to, your final answer, you say, well, does that make sense? And you say, well, sure. I don't know if you've driven a Porsche. I haven't. It doesn't matter. 7 is a reasonable, right? 10, like it's under 10, it's around 10, fine. They're going 100 meters. That's about a football field. Okay, that's reasonable. Whatever. I don't know if it's exactly right, but I know it shouldn't be 700 seconds, right? Or 756. You did something wrong. Okay.
Right.
So, and then we got to be careful. We might have even done the Honda if I'm not paying attention. It's the P. So make sure we use the P values. Awesome. Do the same thing for the Honda.
Mm-hmm.
In fact, you can just do it real quick if you want me to. Because it would be, yeah, square root of 0, but minus be plus 4. A is again, now it's 3/2. Or maybe I didn't do 7/4 correctly. No, 3/2 is that. Be careful going too quick here. Oh yeah, and then it's the 1/2. That's where that 4 came from. Great. So 3/2. And then 100, again, it's 100 divided by, well, the same 2 1/2, but just 3 over here. So it looks like,
Why is it 3/2?
because our A, so if we go back again, that's the coefficient on our variable here. The acceleration of the Honda is 3,
3.
but it's also 1/2.
So it'd be 3 times 1/2.
3 times 1/2, exactly.
Okay.
And remember that 1/2 simply comes from your equation,
Right.
the original equation. So then it looks like 200. Oh, square root. No, okay, I'm going too quick. But it's 600, square root of 600 over 3. I guess since you are putting these in right
Or
now.
would that not be negative 100 under the square root?
So yes, well, it would be minus 4 times 3/2 times negative 100,
Mm-hmm.
which comes to positive right there. Is that good?
Okay.
Do you want me to write it out?
That's fine.
Okay, cool. So then, yes, I forgot you're putting these in, so you can check, I guess, right now. So it looks like Honda goes 8.16. I don't know if they're doing, you'd expect the Porsche to win, obviously, and that's what it tells us,
Right.
but you can't rely on that. It might not. Maybe it's got a flat tire or something. But if you can check, I think they're asking for the difference. Oh, see, okay. We already forgot one piece of information because the Honda actually starts 1 second ahead.
Right.
So
you
might,
subtract 1 from that?
I believe so. Let me double check and make sure it checks out. I think.
Yeah, it does start 1 second before.
Yeah. But I want to make sure that you subtract 1 second at the end.
Okay.
I guess that would make sense, right?
Right.
Are you able to put it in right now and check?
Well, the answer, I already have the answer. It does say the Honda wins.
What is the answer?
The Honda does win.
Okay, and that makes sense when you subtract the second.
Right.
And were they asking for the final answer?
By how many seconds?
So then it should be 0.4.
Yes.
Okay, great. So then the answer, yeah, of course, like I said, subtract the second, and that, you think about it, and it does make physical sense, right?
Right. So you subtract 1 second from that, and then subtract the 2 times.
Yeah, exactly. To get that final answer, yes.
Okay. All right.
But again, as it sounds like you might know already, you got to make sure that you understand the process, right?
Mhm.
That's why this epic thing really helps out. We extract the variables, draw the picture, and make sure you understand the setup before you even try to get into the equation, right?
Mhm.
And I don't know, you might have to do the quadratic formula on the test. Hopefully not, but just be prepared. You might have to.
Mhm. He usually does numbers that'll check out to be
He does simple numbers usually.
Yeah, because we don't we're not allowed to use calculators.
Oh, okay, then yeah. So of course they'll give you a simple one. Makes sense.
I like that better, honestly.
Yeah, definitely. Yeah, saves time and
calculus 1 and 2 as well.
yeah, exactly. Saves
Helps
time
me-
and make mistake,
Helps me learn like actually what I'm doing.
Right, because sounds like you understand the numbers don't matter. I don't care what the
Yeah.
numbers are.
Uh-huh.
It's about the equations and the variables and getting it done.
All right.
All right, so we got like 5 minutes here. Like I said, we can make up for a few minutes there. I don't think we can get through one. We can start it though, if you want to. Or if you have any other questions, that would be a good time thing to ask about.
I'm just gonna, I'm gonna have another appointment with you, so we could end right here. That's fine with me.
Okay, sounds good. Yeah, if you got, do you have anything on the top of your head at all? Any questions or anything?
No, we addressed
The main ones.
the graphs,
Yeah, yeah.
which that was my main question without any problems. So
Yeah, yeah. Yeah, and you'll get the notes here too. I recommend taking notes. Obviously, do whatever you want,
Right.
but you're going to get these. I know you've been working with Matthew, so you know the drill, I guess. All right, Trent, man, it was good to meet you.
Yep, good to meet you too.
Yeah, just do the same thing to make an appointment, and I'll see you again.
All right, see you.
All right, man, take care.
Yeah, do we want to even try unplugging it, or do you want to do that later? So, I don't know if either of any of these are gonna work. We can have that. Well, I'm not looking at my I mean, unless you got enough charge to last next lesson, you can just take that. I think if now I'm gonna order one. For mine. Yeah, it was a long shot. I just had an extra. Yeah, yeah. I'm glad it's sort of working. Okay. I don't know what it's the connection there. I'm not even gonna touch it, but this is no issue. It's that okay. So something there, like it's gonna eventually fail. Yeah. So I got to get one that's gonna work, and this one looks like it might work. Got prime. Yeah. This is a guess. So here's another computer. Yeah. Okay. Because I had that other one too, but it's shit. So I use this. That's just. I mean, we got the information here. This is essentially the picture FSP Group Inc. Well, they're never the same. Okay. But these code gaming. I mean, the model of the computer should. I've got all that information. Yeah, it should be the same. So that didn't work. Yeah. You want to look on Best Buy's website. I don't have time to go around and get it, but that was my next, like, if it were that urgent, that's what I would do. Okay, that's fine. So if you want to go down to that Best Buy, is this the original? Yeah. Yeah, it's what you do. But it wasn't a MATLAB. It doesn't have your programs. So it's just a log in. Yeah. But if you want to go to Best Buy after this and bill me for your time, do it. I gotta go do wrestling. Thanks for coming out. Actually, do you think I could find one? Okay. They'll have a universal one that will work, but it's not going to work forever. So I gotta get the right one. Okay. And I'll order that tonight.